Our second lecture on differential calculus, and today we will be starting with relations and functions. Okay, so previous day we talked about set theory, some basics of set theory, and we learned the different types of sets that we have. So I talked about real number set, integer set, rational number, etc., but we did not talk about one set. Can you say what it is? Yes, it is the set of the complex numbers. And why did not we talk about that? Because in your entire calculus, you will be only dealing with real valued functions. Okay, so we will know what is a real valued function is as we go into the chapter. So let's start. Now, today the first thing would be cardinality of a set. So what is the cardinality? The cardinality is the number of elements present in a set. Okay, suppose that you have a set A which has suppose 3 elements. So cardinality of the set would be 3. That is, the number of elements in the set is 3. So we will represent this as n of A is equals to 3. Okay. So now the important topic for the first topic for relations. This was just a basic knowledge that you should know. It would be Cartesian product. Cartesian product of two sets. So what is a Cartesian product? A Cartesian product, listen very carefully how it is defined. A Cartesian product is a product of two sets x and y in the order denoted by x cross y. Okay, if I don't write, you will not understand. Of course, let me write there. First, let's see the statement. Then we will understand what it is. PDT means product. Okay, Cartesian product of two sets x. This is cross. Okay, this is not x. This is not x. This is cross multiplication product. X cross y x cross y and is given by x cross y is equals to x comma y. This is the ordered pair. Okay, ordered pair x and y such that x belongs to x, the set x, and y belongs to the set y. So what does this mean? This actually means that it contains this Cartesian product is also a set. Okay, so this set will contain ordered pairs of the form x comma y such that x belongs to x will come from this set, and y belongs to y will come from this set. Okay, so this Cartesian product set will contains the ordered pair x and y. So now how many elements will be there in this? a set of Cartesian products. So like suppose that the set X contains P elements and the set Y contains Q elements. So the number of elements in X cross Y will be P into Q. Okay, now let's take an example and understand this. It will be clear. देखो, suppose आपका X है 1, 2, 3 and आपका Y set जो है that is 4, 5 and 6. Okay. Now, if I will write the Cartesian product of these two sets, okay, Y, it will contain ordered pairs such that X will come from this set and Y will come from this set, and it will have all possible combinations. Suppose I have 1 from this set, 4, 1 and 5, 1 and 6. Next, taking 2 from X, we can take 4 from Y, 5 from Y, 6 from Y. Taking 3 from X, we can take 4 from Y, 5 from Y, 6 from Y. Okay, so how many elements are there? Count 1, 2, 3, 4, 5, 6, 7, 8, 9. So, what is the order of X? 3. Order of Y? 3. So, order of N cross Y, sorry, X cross Y is 3 into 3, as you can also see on count the elements from over here, and you can see that 9 elements are there. Okay, so this is everything about Cartesian product of a set of two sets. Okay, Cartesian product of two sets, not one. So if you have understood this, then we can start with the main topic, that is relations. Okay, now what is a relation? How are we defining it? Let's see the definition first, then you will understand. Now a relation from X to set Y is a subset. Okay, subset, important thing, subset of X cross Y, that is the Cartesian product. ये जो यहाँ से हमें सेट मिल रहा है Cartesian product X cross Y, okay, the relation from set X to set Y would be a subset of the Cartesian product set. Okay, and there will be one criteria, that X and Y are non-empty. अगर empty हो गया X and Y, then you cannot define a relation. Okay, now how will we denote this? Let's see how we will denote a relation, because in question you will be not given like A is a relation like from X to Y. No, you will be given some symbols and notations and you have to understand that. Okay, so we will write this as R. R is the relation from set X to set Y. Okay, and this is how we denote this. In exam, in your question, it will be given like this. So this is important to know. Okay, now I don't know whether you know this or not, that if a set has, suppose that a set X has A elements, then the number of subset would be 2 to the power A. Okay, now if you don't know, I will be just telling you how this comes, because you should always know how things are coming instead of mugging up the formulas. Okay, so see, अब देखो x में मान लो कि ऐसे नंबर्स है, n a एलिमेंट्स है, ठीक है, सपोज a1 a2 up to a elements है. Now you have to form a subset from this. Let us assume that to be a. Okay, now each of these elements in set X will have two choices. Either it will come in this set X or it won't. So two choices. Whether it can come or it won't. Similarly for A2 we have two choices. For A3 we have two choices. And so on. For AA we have two choices. So if you multiply 2 into 2 into 2 a times, you get 2 to the power a. So that's how a subset is formed, and that's why the number of subset of a set is 2 to the power a. Okay, so this is how it comes, the formula comes. There is also one more way to derive this formula by using binomial expansion, but I don't know whether you know that or not, so let's skip that, because if I say, you won't understand. Okay, you should know a binomial expansion of a particular number, of a particular expression, otherwise you can't understand. If I write things, you won't understand, so let's skip that. So now you have understood that a set X of n elements will have 2 to the power n subsets. So now let's talk about the relation thing. See, so suppose that order of X is P. Okay, but we were talking about the relations from here and y. Suppose the order of P is X is P and the order of Y is Q. So what would be the order of X plus Y? Into Q? Yes or no? And what is a relation? A relation is a subset of this Cartesian product set. So how many relations can you define from X to Y? So total number of relations from X to Y is 2 to the power P into Q. Okay, so you can have total 2 to the power P into Q relations. This is very important. Okay, please make a note of it. So let's do one example and understand this well. Suppose X has two elements, A and B. Sorry, this is an example. Okay, and Y has two elements, 1 and 2. तो X क्रॉस Y, आपका जो सेट X क्रॉस Y जो कार्टेशियन प्रोडक्ट वाला सेट है, उसमें कितने सारे एलिमेंट्स होंगे? 2 into 2 4. So number of relations from X to Y will be 2 to the power 4, that is 16. Okay, cool. Now next let's move to the next topic, that would be types of relations. Types of relations. Number one, let me use this color. Yeah. Number one would be empty relation. What is empty relation? Let's see. A relation having zero elements is an empty relation. Okay. So a relation having zero elements. Okay. Basically, it is an empty. You can understand, like, you know what is an empty set is? A set which has no element. Pi. Similarly, an empty relation is a relation having zero elements. Number two. Okay. Number two would be inverse relation. Okay. Inverse relation. So we will understand an inverse relation by one example. Okay. So suppose let R be a relation from set X to set Y, and suppose R is equals to x comma y, such that x belongs to x and y belongs to y. Then how will you define R inverse? R inverse will be defined by y comma x, such that x comma y belongs to R. Just the opposite, the reverse. Okay. So let's understand this with help of an example. Like suppose R is equals to 1 comma a, 1 comma b, 1 comma c. These are the elements in R. Then R inverse will just have the opposite thing. A1, B1, C1. Okay, cool. Now, yeah. So now we will discuss about the basic terms. Okay, so now we will be talking about a few terms such as domain, codomain, and range. These are mathematical terms which will be important in studying relations and functions. Okay, these are mathematical terms, so you should understand what does it means actually. Okay, so now suppose I have a set. Let me represent this as like this: one set X and one Y. Okay, now I have elements in X like A, B, C, and in Y I have 1, 2. Okay, now suppose A is related to 1 by some relation R, B is related to 2. Okay, and suppose C is not related. It can happen in a relation. In a relation, it may happen that some of the elements in X is not related to any element in Y. Okay, so now you see that how we define domain. So domain would be all the values of X which are related to some element in Y. So domain would be, let me write it like this: X such that X comma Y belongs to the relation R. So now here your domain set would be A comma B, not the entire set X. Okay, this should be kept in mind. The domain is only A comma B, not A, B, C. Okay, now range. Let's talk about range. Now here in general we will define range as the elements Y such that X comma Y belongs to the range. Okay, the set of all the elements y such that xy belongs to R. Now, in this case, in this particular example, the range would be 1, comma 2. Now, it may happen in some case that your, like suppose, let me take another example. XY, they are related. Okay, and A, B, C, and 1, 2. So suppose it may happen that A is related to 1 and also B is related to 1. So in this case the range would be, for this, the range would be only 1, not 1 comma 2. Okay, 1. Only those elements in Y which have a pre-image in X and they are related by the relation R. Okay, that is a range. That would be the element in your set range. Now, the next term, that is codomain. What is codomain? So your codomain would be the entire set Y. The entire set Y. So this is a very important difference between range and codomain, which would be used further when you will learn functions, when you will learn onto functions. That time you will be using range and codomain very conceptually. Okay, so you understand now only what is the difference between a range and a codomain. I'm saying it again. Range is only the set of those elements which are related to some element in X. Okay, and domain would be the entire set Y. The entire set Y would be the codomain. So yeah, in this case, the codomain is equals to the range. As you can see in the first example, in this example, these two are there in the range, and it would be also there. This entire set Y has only two elements, 1 and 2, so this would be the codomain as well. So your range is equals to the codomain. But in the second example, is example 2, and let me write this as example 1. Okay. In example 1, your range is equals to codomain. In example 2, your range is not equals to codomain. Yes, your codomain is 1, comma 2, but your range is only 1. So this is the difference. Okay. Okay, very good. Now next topic would be right here, types of relations on, mind it, on set A. So how do we define this? Till now we have read about relations from one set to another set, like from set X to set Y, or from set A to set B. But now I am defining these relations on set A. Okay, so how does this look like? See, let R be a relation from set A to the set B. So if you have like the X set and Y set equal, then you will call it as a relation on set A. So it may happen in your exam, they will not give in this form. They will only tell you that a relation on set of natural numbers, a relation on set of real numbers. So a relation on a set of real numbers would be like this is R to R. Don't be confused, this is the set of real numbers, this is the relation R. Okay, so now let us do the types of relations on set A. Change the color. Yeah, so number 1 would be reflexive relations. Reflexive relations. Okay, So reflexive relation would be, let there is a relation R from set A to set a relation on A, then R would be reflexive. Okay. If X is related to X, exists for all X belongs to A. Now this is the symbol for all. So the next time I will use this symbol. You should know mathematical symbols, like this is the symbol of for all, then this is the symbol for belongs to. Okay, so that you don't have to write much, because the mathematicians are really lazy. Okay, so yeah, so now this is what a reflexive relation is, that for all the elements in the set A, X should be related to X by some relation R. Okay, now one important point to be noted is, write it as a note, that it is not necessary that if it is not necessary that only X related to X exists for a relation to be reflexive. Okay, exists for a relation to be reflexive. Now let us understand what does this mean. Suppose always you should try to understand by examples, because it becomes clear. See the example. Suppose you have a relation from set A to set A, relation on A. Now suppose the set A is defined by A, B, C. Now you have a relation R which will have elements such as, now relation would be a subset of the Cartesian products of the set A and A cross X, A cross A cross A का जो Cartesian product का set है उसका subset होगा R. Suppose that R is having elements like A comma B, A comma A, B comma B, C comma C, A comma C. Okay, suppose these are the elements in your Cartesian product, in a relation. So now this relation would be a reflexive relation, because all the elements for all X belongs to A, we are having these elements in the relation set C. All X, for all X belongs to A, X is related to X. You can see in this relation. So even if some other element exists in the set of relations, it is not that your relation is not reflexive. Your relation is reflexive. Okay, so this is what you should know. It is a common mistake in exams. Okay, so yes, we have done with the first type. Now we will do the second type. Okay, so it would be number 2. Change the color. Number 2 would be symmetric relation. What? Symmetric relation. So what is a symmetric relation? So R is called symmetric. Again, it will be the same. R is a relation on set A. So I am not writing that again and again. So R is called symmetric if for x related to y, there exists y related to x in your set R for all x comma y belongs to R. Okay, now let's see with an example. So example, suppose same, I will take the same thing. Suppose I have, now your R would your set A would be the same, A B C, as I have said. All the examples that would be done, I will use this set of A. Okay, I'm not changing it. So now suppose in the relation I have A comma A comma B, B comma A, B comma B, and C comma C. Now let's check. I have A comma A. So if it is, so both x and y are A, so this condition is satisfied for this element. Similarly for B comma B and C comma C also it is satisfied. Okay, now let's see for this. So I have A comma B and I have B comma A. Yes or no? I have it. So this set, this relation is both reflexive and symmetric. Okay, so R is both reflexive okay. Now some of you may have a doubt that, ma'am, in this question we don't have A comma C, C comma A, B comma C, C comma B. So is it right that this is still symmetric? Yes, it is right. It is correct. Why? Because you see, what we have learned that it is not necessary that all the Cartesian products would be there in your relation. Relation is a subset of the Cartesian product. So my relation is defined like this. Okay, my relation is defined like this with these elements. So for all xy belongs to R, not for all xy belongs to A, it is necessary that this condition would be true. Okay, for all xy belongs to R, if this condition is true, then your relation would be definitely symmetric. This is a common confusion which I also used to have when I was young, when I prepared for my JEE. So please clear it. Okay, next is the third type of relation, that would be so what would it be? It would be transitive, new term, transitive relation. So what are transitive relations? So now same set, same relation, R is a relation on A. So R would be transitive, R is transitive if, what does that mean? If for x related to y and y related to z implies x related to z. Okay, if this condition happens for all xy and yz belonging to R, then my relation would be reflexive. Okay, now again I will take the example, like say, suppose I have R, A comma B, A comma A, B comma A, B comma C, A comma C, and B comma B. Okay. Now see, let us take the first element. Let us take A comma B. B comma A is also present. And what would this to give? A comma A, which is present. Okay. Now next, A comma A, A comma A, and let me take A comma B. So for this two, I have A comma B in my relation. This element is present. Yeah. So by taking all the elements, remaining elements, you can actually prove that for all x, y and yz, you will get xz in this relation. So this relation is transitive. Okay. So yeah, now you have got it. And similarly, it is not necessary that for all the elements in the Cartesian product of A cross A has to be present in the relation. Relation would be a subset. So whatever elements will be given in your relation, you have to check only for those. Okay, don't use your brain much and don't get confused. So next, let me do the third type, that would be equivalence relation, which is basically very easy. Equivalence relation is defined as a relation which is which is reflexive, symmetric as well as transitive. अगर तीनों conditions एक relation ने satisfy कर दिया तो relation को हम equivalence relation बोल सकते हैं. ठीक है. If it is reflexive, transitive, and symmetric, then my relation is equivalence relation. Okay, then we will call this an equivalence relation. So let us do one question. Okay, बहुत टाइम से कुछ क्वेश्चन तो सॉल्व नहीं किया. Okay, so suppose what question shall we do? Acha, let us do like this. Let us define a relation like this. Okay, in question it would be given like this on most of the questions, so just see how it will be given. R will be defined as a relation xy such that x divides y and x is belonging to the set of natural numbers and y will also belong to the set of natural numbers. Now you will have to read the question very carefully. Like अभी I will show you कि कैसे मतलब ये जो है ना नेचुरल नंबर्स इधर जो दिया है x and y belongs to natural numbers, अगर ये सेट नेचुरल नंबर ना हो के रियल नंबर्स का सेट हो जाए तो क्वेश्चन का आंसर कैसे डिफरेंट हो जाएगा. सो read the question very carefully. Okay, like many of you don't read the question and just initial देख के ये क्वेश्चन बहुत ईजी अभी हो जाएगा, और ऐसे करके आप गलत आंसर मार्क करके आ जाते हो. ठीक है, तो लेट्स सी. First we will check for symmetry. No, first we will check for reflexive always. Yeah, first we will check for reflexive. Like what will be reflexive? R related x should be related to x. So x divided by x would be 1, and 1 belongs to the set of natural numbers. So yeah, your set would be your relation would be reflexive. Now next we will check for symmetry. how to check if x is related to y, then y should be related to x. Now suppose that x divided by y would give me some number k which belongs to n. Okay, some natural number k would come. But if I do the opposite, y by x, that would be equals to 1 by x by y, that would be equals to 1 by k. Now 1 by k, where k is a natural number, where k belongs to n, would definitely not be a natural number. It would be a rational number. Yes, this is a rational number. 1 by k belongs to q. It's a rational number. So this is not symmetric. Okay, now if like this is one trick, or not trick, this is a rule. If you have to prove something true in mathematics, any statement, then you have to prove it is in a general form. You cannot take example and proof. But if you have to prove something wrong, then you can take an example and show that for a particular element in that set it is not satisfying. Then it would like अगर एक भी element के लिए वो condition true नहीं है, तो then it is obviously false, because if it is true then it have to satisfy all the elements should satisfy that, right? तो example में देखती हूँ कि अगर मैं 2 और 3 ले ली है, तो 2 और 3 नहीं, हम 6 और 3 लेते हैं, that would be better. तो 6 divided by 3 would give me 2, which is a natural number, but 3 divided by 6 would give me half, which is not a natural number, right? So this is not symmetric. Sorry, this relation is not symmetric. Next, I will check for transitive. Number 3, transitive. So now suppose x divided by y. Now first you erase. First, what is a transitive relation? How is a relation transitive? If x is related to y and y is related to z, then x must be related to y, x must be related to z. Only then your relation would be transitive. So now, suppose that x divided by y is some integer k, and y divided by z is also some integer k. So I can write this as x equals to, like, do this k1 and k2. Yeah. Suppose yes, so we can write y x equals to k1 y. अरे जस्ट मल्टीप्लाई किया इधर y से और इधर y से, ठीक है. और इसको मैं ऐसे लिख सकती हूँ कि y इज इक्वल्स टू k2 z. Now this is my equation 1, this is my equation 2. Now see, if I put the value of y from equation 2 in equation 1, what it will be? Yeah, it will be k1 k2z. So it would be k1 into k2z, which would be k3 into z. Now x is related to y, which means x divided by y would give me k1, where k1 belongs to natural number, and y divided by z equals to k2, where k2 belongs to natural numbers. Now you know that the product of k1 and k2, product of two natural numbers, is also a natural number. So k1 and k2, which is k3, will also belongs to natural number. So you can see that x divided by z would also give me one natural number, which means x divided by z, x is actually divisible by z. Okay, because division of two natural numbers is also a natural number if it is divisible. Of course, if it is not divisible, then it is not a natural number. That is what your relation is given. Like, so if this is true, then and k3 belongs to natural number, so we can say that x is divisible by z. That is, z divides x. So x is related to z. That means this relation is what? This relation is transitive. Okay, so you have to do proofs like this. Yeah. So what can I say? This relation R is symmetric. Sorry, not symmetric. This relation R is reflexive and transitive, but not symmetric. So this relation R is not an equivalence relation because it is reflexive and transitive and not symmetric. Okay, did you understand, all of you? Okay, fine. Acha, so now let us do one more question. This would be a good question, a conceptual one. I will first write the question and you will think about it for 2 minutes. Then I will solve. Okay. Now see the question. Find the number of, what is happening to the pen? Find the number of reflexive relation from set A to set A, which means this is a relation on set A where A is equals to 1, 2, 3, 4. This is a very important and very good question. Please think about this question for 2 minutes, then I will tell the solution. Okay, so I think you have already thought, or some of you may have solved it as well. And if you have not, then you can still pause the video and think, but now I will give you the solution. Okay, so see, now we will solve this type of questions. Okay, you should do practice and you should know the basics, then only you can do. See, अब relation क्या होता है? Relation is a subset of the set A cross A of the Cartesian product. तो कितने सारे एलिमेंट्स हैं यहाँ पे? 4. So how many elements would be there? How many ordered pair would be there in A cross A? Number of elements in A cross A, how many? 4 into 4, that is 16. Okay, now for a relation to be reflexive, what have you learned? For a relation to be reflexive, and now it has been said that it is a from set A to set A, that means all the elements would be there. the entire set A would be your domain. Okay, so if I have to make this a reflexive relation, then 1 comma 1, 2 comma 2, 3 comma 3 and 4 comma 4 must be present. इसके साथ और भी एलिमेंट्स आ सकते हैं, ठीक है, पर दिस 4 एलिमेंट्स मस्ट बी प्रेजेंट. उसके साथ तुम कोई किसी भी परम्यूटेशन और किसी भी कॉम्बिनेशंस बना लो एलिमेंट्स लेकर ए से. दिस 4 मस्ट बी प्रेजेंट फॉर द रिलेशन टू बी रिफ्लेक्सिव. तो 16 में से 4 एलिमेंट्स तो होगा ही एकदम पक्का. तो रिमेनिंग कितना हुआ? 12. रिमेनिंग नाउ ये जो रिमेनिंग 12 ordered pairs हुए, which call these ordered pairs, we have already discussed that in the beginning. Ordered pairs. अब यहाँ से जो 12 remaining ordered pairs हुए, these 12 ordered pairs will have two choices. They will have two choices. Either they can come in the relation or they may not. So the total number of reflexive relations would be 2 into 2, because each of these ordered pairs will have two options. Either they can come in the set of relations or they may not. Yes or no, yes or no. So each of them will have two options. And 12 times, so that would be how much? 2 to the power 12. So 2 to the power 12 would be the number of reflexive relations from set A to set A. Okay, if you have not understood, I am telling it once again. In total number of elements in the set of Cartesian products would be 16. Yes or no? We have already learned that if a set A has 4 elements and the set B A has 4 elements, because it is from set A to set A, so the total number of elements in the Cartesian product would be 4 into 4 16. ठीक है. अब हम इसमें से जो 4 मस्ट ऑर्डर्ड पेयर्स, these are the must ordered pairs. Must ordered pairs. ये जो 4 ordered pairs है, this must be present in this relation. Okay. Now इस 4 ordered pairs को छोड़ के बाकी जो 12 remaining ordered pairs है, इनके पास two choices each. Either they can be there in the relation or they may not. So your total number of reflexive relations would be 2 to the power 12. Okay, this is your answer. So this question was one I found to be interesting and tricky. बाकी सारे questions तो वैसे ही same type pattern के आते हैं, जैसे कि they will give you some relation and you have to say that whether the relation is only reflexive or only symmetric or only transitive or any two or equivalence relation, like that. Okay, so I will be giving you 2 questions as homework. It will be given in the PDF format along with the answers, because it is MCQ questions. So please do that, and I hope that you have understood the lecture. If you have not, then please tell in the comment section below which part you have doubt in. Okay, and in the next lecture we'll be starting with functions. So एक बार तो आप लोग अपना NCERT बुक जो है, NCERT बुक थोड़ा देख लेना, और अगर आपने कोई बुक्स खरीदे हैं तो उससे भी थोड़ा देख लेना, क्वेश्चंस प्रैक्टिस कर लेना, बहुत इम्पोर्टेंट है. एंड आपका जो एक बुक आता है NCERT एग्जाम्पलर, वो बुक बहुत अच्छा होता है फॉर योर मेंस लेवल. एक्चुअली रिलेशन से क्वेश्चन सिर्फ मेंस में आता है. और अब जो हम नेक्स्ट क्लास से स्टार्ट करेंगे functions that would be important for your advanced and मेंस as well, but रिलेशन से क्वेश्चन सिर्फ मेंस में आते हैं, तो आप एनसीईआरटी एग्जाम्पलर एनसीईआरटी के क्वेश्चन सॉल्व कर लेना. सो ओके, थैंक यू एंड हैव अ वंडरफुल डे.